So in this video, we'll do some practice problems on the topic of integration of rational functions. And please look at the current problem now. Usually, the first step is to check the degree of the top and the bottom. So please take a good look. The denominator has degree 3 and the top has degree 2. So it's fine. We can carry on our partial fraction decompositions. And the first step is to factorize the denominator. So I think this one is easy to factorize because I can pick out the x as the common factor. And inside the bracket, we actually have x squared plus 4. And you see, x itself is a degree 1 factor. There's no doubt about that. And x squared plus 4 itself is degree 2 because of the fact that you cannot break down x squared plus 4 further because x squared plus 4 is a polynomial that has no real roots. And from there, we can actually start the partial fraction method. See, the partial fraction method means that depending on the number of factors you have, you actually should have the same number of smaller pieces of fractions on the right-hand side. So based on the factor, which is x and x squared plus 4 respectively, I put it in the denominator of each term and the top because the first factor has degree 1. So the top is a constant. And for the second fraction, we actually have a degree 2 factor. We actually need a degree 1 factor at the top. So it's going to be bx plus c. And of course, from there, you have to find the constants ABC, but we'll skip some steps and we have to speed up a little bit. You see, the fact is that you have to use a common denominator on both ends. And after canceling out the denominator, you are just comparing what you have on the numerator. And from there, you are asked to find the ABC. And we'll try to be a little bit fast on this calculation. Please look at all the steps that I put out on this page, and you can check the calculation on your own. If you replace x by 0, you can actually find the value of the constant a to be 1. If you replace x by 1 and minus 1 correspondingly, you can actually get two equations in BC. So it means mathematically you have to solve the two equations in two unknowns, and I believe that you're able to solve that. After adding two equations, you can get 2b equals 4 because you eliminate the variable c in that case. And after getting b equals 2, finding c is easy. Keep these three constants in your mind. We'll get back to the integration problem now. So you see the big rational function now is decomposed into two smaller pieces of partial fractions. And to integrate it is definitely easier than dealing with the big rational functions. For example, the first term is going to be just ln x. Anyway, integrating a partial fraction with a degree 1 term at the bottom is always clear. And the more difficult part is about integrating a rational function with degree 2 in the bottom. So the typical way is to split the calculation into two parts. The first part has the x term, the second part only has the constant term in the top. So you see the hint I gave you previously in part 2 of this topic is that whenever you have the x term at the top, the hint is that this calculation always gives you half times ln of x squared plus 4. Obviously, x squared plus 4 comes from the denominator, and you're taking half is kind of fixed, times ln of x squared plus 4. If you're curious why we're getting that, you can review the part 2 of this topic in my video series, or you can think about using the u substitution where u is actually x squared plus 4. When you try it out, you'll see why. And the second part is totally different. For the second part, we have to use the hints where 1 over x squared plus a inside the integral. When you integrate that, you're getting 1 over square root of a times inverse tan of x over square root of a. So anyway, if you know these two facts, we can actually write the answer pretty quickly. So the second part is going to be 2, which is the constant attached to the x term at the top, times half times ln of x squared plus 4 inside the big brackets. And for the last bit, the 5 is the constant attached to the fraction. And 5 times 1 over 2 times tangent inverse of x over 2. 2 because it's actually square root of 4, because our 4 is actually a, right? And essentially, that's the answer to this problem. Let's try out one more. Let's look at the current problem instead. You're asked to integrate another rational functions, and the first step is to check the degree. Now it is good because the top has a degree less than the bottom. And we can start off our partial fraction decomposition. Before that, we need to factorize the denominator. Now the factorization is pretty clear because we can pick the x squared as the common factor out. And inside the bracket, we actually have x minus 1. And you see x squared is not the degree 2 factor because x squared means it's x times x. So altogether, you actually have 3 factors. Each of them is degree 1 and x times x is repeated. So it belongs to the case where the partial fraction, we have to write it down based on the fact that we have the repeated factor, right? And the fact is that because we have 3 factors altogether, so there should be 3 pieces of partial fractions. And let me write down each factor correspondingly to each piece of partial fractions. And because each factor is degree 1, I just have to use the constant at the top. And because of the fact that x is repeated, and also in the partial fraction method, we never want 2 pieces of partial fractions to be the same, so we have to increase the power of the second piece by 1. It matches up with the fact that the term x as a factor is repeated 2 times. And anyway, from there we have to do something like the common denominator and solve for the ABC. Please look at my current steps. If you make the common denominator for the left and the right side, you should be just comparing the numerator because we can cancel out the denominators when they are the same. And to find ABC, I write down all the steps. In case if you are doing your calculation correctly, you should be getting the values ABC I found here in the right hand side. The trick that I used is based on the clever choice of the substitution of the values of x. For example, if you choose x equals 0, I can make these 2 factors 0, right? So you can solve for b for the first one. And similarly, if I make x be 1, I can make the first factor 0 and the second factor 0. In that case, you can solve for the c. And the remaining case of a should be quite easy because once you have the constant b and c, you can choose any other value of x to find a, right? Because you have only one constant left you need to find, and to solve it is just like an equation like this, and you can randomly choose any value for the last one. Anyway, these are the 3 constants we have. So let's keep it in your mind. We'll try to do the integration now. So you see, essentially, you're asked to integrate this after putting the values a, b, c in. And the first term, of course, is 0. And the last term has the degree 1 factor in the denominator. So we can easily write it as 2 times ln of x minus 1. And the middle term is also pretty simple because basically you are asked to integrate something like x to the power negative 2. And it is a power rule, right? And power rule means I can put it as the answer. Of course, you can write it in a slightly better way. You can write this one as the final answer. You see, because of the fact that the minus 1 can be cancelled, right? I mean, the minus 1 can be cancelled, and x to the power minus 1, you can write it as 1 over x, of course. And that's basically the final answer to this problem.